Hello everyone, welcome to Unlock Maths. Today we have to discuss compositions of permutations. So here we have given these two permutations alpha and beta in set as 6 and we have to find this alpha beta and beta alpha. This is a compositions of two permutations alpha and beta, which is also called as a product of two permutations, right? Now we know that permutation is a bijective function which maps from set to itself. That means this second row element, these are the images of this first row element, right? So for this permutation alpha, we can write this is as here this alpha of 1 is equals to 3. That means here this first element 1 maps to 3. Similarly, this 2 maps to 1, 3 maps to 4 and so on for this permutation alpha. So here we can write this alpha of 2 is equals to 1 and so on. Here we have. Now for this permutation beta, we can write this beta of 1 is 6, right? That means for this permutation beta, 1 maps to 6. 2 maps to 4 and so on. Yes, here alpha and beta, these are the two functions, right? That means here this alpha beta is a compositions of function, right? Now when we have to find this alpha beta, that means first we have to operate this beta, right? That means when we have to find alpha dot beta of this first element 1, first here we have to operate beta on this first element 1, right? So when we operate beta on this 1, yes, here we have this 6. That means here we have to write this is beta of 1, this is 6 here, right? And alpha of 6 here we have this is 5, right? Similarly when we have to find this alpha beta of 2, that means first we have to find value of beta 2. Beta 2 is here, this is 4, so we have to write here 4 and next we have to operate this alpha on this 4, right? So alpha of 4, this is here 6, right? Similarly, we have the other values. Now we have to find this composition alpha beta on this element 3. So we have to write beta of 3. Beta of 3 is here 5 and we have to operate then alpha on this 5. Alpha of 5 is here 2, right? Similarly, we have these values. So we have find all these values here and we have to write down this is in this composition alpha beta, so that here we have this composition. So in first row we have to write all these elements 1, 2, 3, 4, 5, 6, right? These are the elements of set as 6 and we have to write down all these values which we have find here. So this is here 5, this is 6, 2 and this is here 3, 4, 1. So we have find this composition alpha beta here, right? Now let's try to find this composition in another way. For finding alpha beta, first here we have to write down this alpha, then next here beta. We have to find this product alpha beta, right? So first here we have to write down in first row these elements 1, 2, 3, 4, 5, 6. Since these two permutations are defined in set as 6. This is here we have write down alpha and this next permutation is beta here. Now this is a composition of two permutations alpha beta, right? That means first we have to operate this beta function here. So this composition is carried out from right to left. And here we have to observe this beta element. Here 1 maps to 6 and we have to check here in alpha 6 maps to 5, right? So here 1 maps to 6 and 6 maps to 5. So here we have to write down this 1 maps to 5 and we have to write down this 5 here. What we have done? We have checked this beta element first. 1 maps to 6 and here in alpha 6 maps to 5. So here we have written down 5. Now in permutation beta 2 maps to 4 and 4 maps to 6. So here we have to write down 6. Yes, we have to carry out this composition from this right to left and we have to move here from this top to bottom, right? Similarly 3 maps to 5 and 5 maps to 2. 4 maps to 1, 1 maps to 3. 5 maps to 3, 3 maps to 4. 6 maps to 2, 2 maps to 1. So here we have find this composition alpha beta. This composition of permutation is carried out from this right to left. This composition is carried out from right to left by moving from top to bottom and again from top to bottom. So here we have find alpha beta. Now we can check that this alpha beta which we have previously find here. Here we can check that this two composition alpha beta. In first row here we have this element 1, 2, 3, 4, 5, 6 and same here, and in second row here we have this 5, 6, 2, 3, 4, 1, right? That means we got same composition alpha beta. Meaning of this both methods are same. Just here writing practice is different and this is to understand how the composition is carried out, right? So when we have to find composition, we will use this method, right? And we have to understand that both meaning of this both methods are same here. Now we have to find this is beta dot alpha. So we will carry it out by this way. So first here we have to write down beta and then next here we have to write down this alpha here. Here we have to find this composition beta alpha. So we have write down this is as a beta and this is alpha here. Now first here we have to operate this alpha function, alpha permutation, right? So here we have to carry out this composition by this right to left. For this first here we have to write down this element 1, 2, 3, 4, 5, 6. This is in first row. Now we have to check alpha permutation. 1 maps to 3 and here 3 maps to 5. So here we have to write down 5. In alpha 1 maps to 3 and in beta 3 maps to 5. So this gives 1 maps to 5. Similarly here 2 maps to 1, 1 maps to 6, 3 maps to 4, 4 maps to 1. In alpha 4 maps to 6, 6 maps to 2, 5 maps to 2, 2 maps to 4, 6 maps to 5 and 5 maps to 3. So this is here we have find composition this beta alpha. So here we have carried out this composition by right to left by moving from this top to bottom and again from this top to bottom. This is here we have find beta alpha. When we observe these two permutation, we get here this is alpha beta not equals to beta alpha. This means composition of permutation is not commutative. So here we have discussed composition of permutation. We have find this value alpha, beta and beta alpha, and we got this result. Composition of permutation is not commutative. So yes, that's it for now. See you in the next video. Thank you. Keep watching.